Hello guys, we are here with the fourth part of definite integrations. Before watching this video, please check the previous parts of definite integration series. Let's start the video with the fractional part of x integration. As we all know that fractional part is represented like this. These are the brackets which are used to represent the fractional parts. There is a function integration a to b fractional part of x dx. As we all know that fractional part of x can also be written as x minus step of x, where these brackets represent step function. So here fractional part of x can be written as x minus step of x, integration a to b x minus step of x dx. So as I said in the third part, by using those three steps, we can do the step function integration, and normal function can be integrated directly. Now I am going to say an important formula which is used to do these kinds of problems. Integration a to b sin power mx cos power nx dx. We can't directly integrate these kind of problems. So there is a formula called Wallis formula. Okay. So this integration can be written as m minus 1 into m minus 3 into m minus 5, so on up till 1 or 2 gets into n minus 1 into n minus 2 n minus 3 into so on up till 1 or 2 by m plus n minus 2 m plus n minus 4 plus so on into total into k, where k is pi by 2 if both m and n are even. M and n are the powers of sine and cos. If both m and n are even, then we have to place k value as pi by 2, and 1 if both m and n are odd, or one is odd and other is even. This is a very important formula. Copy it down. I will discuss the problem on it. I am not rubbing this formula. See, I will write question here. Integration of 0 to pi by 2. Sorry, here the limit should be 0 to pi by 2. Remember that the limit should be 0 to pi by 2. Otherwise, this formula is not applicable. Integration 0 to pi by 2 sin power 6x cos power 4x dx. As both m and n are even, we get the k value as pi by 2. First of all, k is pi by 2 into m. What is m? 6. 6 minus 1 into 6 minus 3 into 6 minus 5. Here we get 1, right? So the last term should be 1. The end should be 1. There should be no negative terms. Okay? Into, what is n? 4. 4 minus 1 into 4 minus 3. 4 minus 3 is 1. So we got 1. By m plus n. 6 plus 4. 6 plus 4 minus 2. 6 plus 4 minus 4. 6 plus 4 minus 6. 6 plus 4 minus 8. And 6 plus 4 minus 10 is 0. So we have to stop it till here. What is our final answer? Pi by 2 into 6 minus 1. 5 into 3 into 1 into 3 into 1 by 6 plus 4 10 into 8 into 6 into 4 into 2. See any cancellations? 5 2s are 3 2s. That's it. So our answer is 3 pi by 2 into 1 by 2 2s 4, 4 4 16, 32, 32 8s, 248. See the calculation is right or not? 16, sorry, 256. 16, 256. So the final answer is 3 pi by 256 into 2, 5 and 2. This is our final answer. I hope you got it. And I will say a method where m is odd or n is even. I am rubbing the formula. Let's take a small question. 0 to pi by 2 sine cube x cos square x dx. Okay. Now one is odd and the other is even, so k value is 1. 1 into m minus 1, 3 minus 1, 3 minus 1 is 2, 3 minus 1 is 2, right? So we should stop here, and here gets 2. 2 minus 1 is 1, right? We should get last term as 1 or 2. We got here 2 and here 1. Next m plus n, 3 plus 2, 3 plus 2 minus 2, 3 plus 2 minus 4. 3 plus 2 minus 4 is 5 minus 4 is 1. So we got the 1. Now solve it. 1 into 2 into 1 by 3 plus 2 5 into 3 into 1. What is the final answer? 2 by 15 is our final answer. Okay. I have given all these formulas in the description. You can check there. Now we'll say some standard results. Integration a to b mod x by x dx is equals to, there are 3 conditions in this. B minus a if 0 is less than a less than b. A plus b if 0 lies between a and b. A minus b if 0 is greater than a and b. This is the condition. And the next is integration 0 to pi sine power mx cos power nx is equal dx. See, this is not Wallis formula. The limits are not from 0 to pi by 2. They are from 0 to pi. You should be careful here. There are 2 conditions in here. 2 times of 0 to pi by 2 sine power mx cos power nx if n is even, or else 0 if n is odd. These are the two conditions. Copy them down. There is one more condition. The next is integration 0 to pi by 2 log sin x or cos x dx. Sin x or cos x, anything. Sin x or cos x. This problem should be done by parts method. It will be somewhat complicated, so we have to remember the formula directly. The formula is minus 1 by 2 log 2, minus pi by 2 log 2. This is the formula. And similarly for integration 0 to pi by 2 log tan x or cot x, nothing but tan x is equals to integration 0 to pi by 2 log of cot x, which results with 0. These are two major standard results that you have to remember. Be careful of limits. This is answer only for the limit 0 to pi by 2. If limit changes, the answer will be somewhat other. Now let's discuss a problem. Integration of minus 1 to 1 step of x less mod x dx, where is a step function. Okay. Here there are two concepts required, which is a step function and mod function properties. Now let's see. First we have to divide these limits from minus 1 to 0 and 0 to 1, because there is mod x present and mod x is negative from minus 1 to 0 and positive from 0 to 1. And same like step mod x, step x also from minus 1 to 0. See, the graph of step x is this is the graph, right? Step x graph is this. From 0 to 1 is this. From minus 1 to 0, anything if we keep in the step function, the resultant value is minus 1. And similarly from 0 to 1, if we keep any value in step x, the resulting value is 0. So here we get minus 1 to 0. Step of some value from minus 1 to 0 is minus 1 into x. As mod x is negative from minus 1 to 1, it becomes minus x plus integration of 0 to 1. Step x is 0 and x is positive, and this becomes minus 1 to 0 minus 2x plus integration 0 to 1 x. Now solve it. 2x square by 2, limits are from 0 to 1, plus x square by 2, limits are from 0 to 1. 2 gets cancelled. 0 minus 1 plus 1 by 2 minus 0. And the answer is minus 1 by 2. In this way we have to solve step x and mod x problems. And now this is a homework problem. Integration 0 to pi x log sin x dx. That's it for today's video. Please like, share, subscribe Satya channel. Thank you.